Alright, this is Quiz 20 Geometry Review Packet. We're just going to go over all the little details that you're going to need to know for your quiz. So, and this is the following figure a parallelogram. Well, there's a couple conditions we need to know to determine and if a four-sided figure is a parallelogram. First thing we need to know is that if the top and the bottom length are the same length, well, which both of them are in this case in this problem. They're both 77 feet. We also need to know if the two side lengths, if they're equal to each other, if they're the same, which is 84 and 84. When we have that, we're good to go. We know it's a parallelogram. So number one is yes, it's a parallelogram. Now, when we're referring to the angles, is the following figure a parallelogram? Well, these opposite angles here and here, they have to be the same. In addition to these two angles, they have to be the same. Since they're not, the following figure is not a parallelogram. Now when we're talking about diagonals, when we're given some diagonals, the diagonal lengths also have to be the same, because this, when two diagonals are crossed, these two lengths are going to be the same, and these two lengths have to be the same to each other. Clearly they're not, so no, this figure is not a parallelogram. Now, these two are different. Two different lengths on the bottom, so no, this figure is not a parallelogram. Alright, in this problem here, quadrilateral ABCD is a rectangle. If angle BDA, so BDA, this angle right here, is 10x plus 32, and angle BAD, this, change up the color, this orange angle, is 2x plus 37. Find the value of x, the nearest whole number. Well, to do this, we know this is a rectangle, and a rectangle has four right 90-degree angles in each corner, so we know that angle's there. We also have to see, when we throw a diagonal in there, like we have, it creates a triangle in our rectangle. And we know there's 180 degrees inside of a triangle. So we do this guy plus the 90 equals 180. So let me type that out here on the bottom. So we got 10x plus 32 plus 2x plus 37 plus 90 equals 180. We combine like terms and solve for x. So 10x plus 2x obviously gets you 12x. 32 plus 37 plus 90 gets you 159. So I'm going to combine like terms. The 10x plus 2x gets you 12x. And then the 90 plus 32 plus 37. That's going to combine to 159. We then subtract 159 from both sides. And we get 21. So 12x equals 21. Divide both sides by 12. So 21 divided by 12 gets us 1.75. So we got to round to the nearest whole number. 1.75 rounded to the nearest whole number is 2. So the answer is A, 2. Alright, looking at this one. Quadrilateral ABCD is a rectangle. The lengths CB and AD are diagonals inside the rectangle crossing at point E. value of x to the nearest integer will be given in diagonal lengths. So they give us here on the side. Might be a little tough to see. Get chopped off. There we go. AE is 7x plus 84. So AE, this length is 7x plus 84. ED is 14x minus 36. Since these are two diagonals crossing each other at point E, that means these two lengths, AE and ED, are equal to each other, so we set them equal to each other and solve for x. So I'm just going to put a big equal sign there. Subtract 7x from both sides, add 36 to both sides. So 84 plus 36 equals 120. So we have 120. We subtracted 7x from both sides, so we get 7x. And now we're going to take 120 and divide by 7, which gets you 17.14. Now 17.14, rounded to the nearest whole number, you get a 17. Quadrilateral ABCD is a rectangle. A CDA, so CDA, this angle down here, is 5x plus 12. Angle DAC, this angle right here, is 17x plus 14. We know it's a rectangle, so that's a 90-degree angle. It's a triangle. I'll highlight that triangle again for you. So this is a triangle. So this guy plus this one equals 180. 17x plus 5x gets you 23x. 14 plus 12 gets you 26. Plus the 90 equals 180. I'm going to just subtract 90 from both sides and say it's equal to 90. Subtract 26 from both sides, so 90 minus 26 gets you 64. 64 divided by 23 gets you 2.78. And 2.78 rounded to the nearest whole number is D3. Alright, looking at this one. Quadrilateral ABCD is a rectangle, length CB and AD are diagonals. They tell us CE and BE. So CE is 9x plus 80 and BE is 16x minus 22. Since we have diagonals in a rectangle, that means that CE and BE, they're of equal length, so you can set them equal to each other. So I subtract 9x from both sides, and we add 22 to both sides, so you get 102 equals 7x. Divide both sides by 7. 102 divided by 7 gets you 14.57, and 14.57 rounded to the nearest whole number is D15. Alright, quadrilateral ABCD is a rectangle. If angle CDA is 6x plus 30, so CDA, this angle down here, is 6x plus 30. BAD, this angle down here, is 11x minus 70. Find the value of x. Well, this one's a little bit trickier. I'll highlight in blue. 3 lines here. We got line AB and line CD. Well, this is a parallelogram, or this is a rectangle. So we know that these are the two same lengths and that they're parallel to each other. Now if I throw a transversal line there, we get all the stuff that we talked about in Unit 2 or Unit 3. This is alternate interior angles, and one of the things you know about alternate interior angles is that they're equal to each other. So we're going to set these expressions equal to each other and solve for x. So we subtract 6x from both sides. So then we have 5x. And then we add 70 to both sides. So 30 plus 70 gets you a 100. Divide by 5 to both sides. And 100 divided by 5 is 20. So the answer is B, 20. Alright, last problem. Dodgeball. A community rec center has created an outdoor dodgeball playing field. To be sure that it meets the ideal playing field requirements, they measure the sides of the field and its diagonals. If AB, this top length, is 30 feet, BC is 32 feet, CD is 42 feet, and AD is 32 feet. AC across the diagonal is 108, and BD is 108. Well, since the diagonals are the same, we're looking pretty good. The right side and the left side are the same, so we're looking good there. However, the top and the bottom, they don't match. They're not equal to each other. Since they don't equal each other, then it's not a rectangle. It doesn't meet the outdoor dodgeball playing field requirements. So the answer is going to be B, no. Alright, ladies and gents, hopefully this helps you out a little bit. If you have any questions, send me an email or come to Extra Help. I'll be happy to help you out. Alright, have yourself a good night.